All right, let's try to finish up this lesson, section 1.1. And I'm not going to review what we've done before. It's been pretty basic stuff, nothing big deal. You could always go back and watch the videos if you missed something or you didn't take notes or you fell asleep or you weren't here or whatever the situation. All right, so let me make sure this is working. Yep. All right. Is today what? The 9th? It's the 8th. Yeah, today's the 8th. All right, so again, all the stuff we're doing, well, maybe not all the stuff. A lot of the stuff we're doing today is pretty basic stuff that you've seen before, okay? Again, this is review chapter. It's the very first section, so you know they're going to start off easy. It'll ramp up a little bit later. Let's do inequalities. Inequalities. So inequalities. So that means that two things are what? Not equal to each other. Very good. So here's the symbol for not equal. All right, just an equal sign with a slash through it. You've seen that almost your whole school life, haven't you? At least in middle school. You probably did that in elementary as well. I don't know. It was a long time ago when I was in elementary, so I can't really remember. It's a little longer for me. All right, so what would we say that? This is less than, okay? Now, a lot of teachers, I've heard anyway, that the kids come in and say, well, Mrs. Smith said it's an alligator and they, what is it, eat the bigger number or something like that or something like that. Okay. We're not in elementary school anymore, so I don't do the whole alligator thing. But I will tell you this. Alex, quickly.
I was going to say it's less than because it points to the small.
Yeah, it is less than. So we read right to left, and you're absolutely right. It does point, okay, to the smaller number, all right? So if I go from left to right, smaller number is going to be on the left, the bigger number is going to be on the right, so it's pointing to the smaller number. Or, do you know where they get that from? An equal sign is this, correct? And so basically what they do is they just take that top, well, they take them both, and they just tilt them. So now the space between here and here is less, isn't it? And now the space between here and here is what? Bigger, okay? So you basically just took an equal sign, and you just went, bam, like this, all right? So this is less, and this part right here is greater than. All right, so that's where they come from. That's where it comes from. All right, and then, of course, this would be greater than, reading from left to right. Now, what if I read this from right to left? Let's do this. What if I said, would you agree with this inequality statement right there?
Yes.
Okay, so you would, most of the time, most of us would read it what? 3 is less than 5. But you could read it right to left, couldn't you? And we're going to actually do that a little bit later in this lesson. You could say 5 is what? Greater than 3. You know, Mr. Hamrick, you said that's a less than. Why'd you say greater? Because it depends what order you read it in. If you read it from right to left, 5 is greater than 3. Yes? I do. The bigger number should be with the bigger part of this, okay? So I could say 5 is greater than 3, like that. Either way, would you agree with both of those statements? Yeah. So 5 is bigger. See, it's the open part, okay? The alligator, okay, I guess. I don't know. Teachers love that. I guess kids like that too. That's fine, you know, but we're big kids now, so, yeah. Yeah, they mean the same exact thing. Yeah, I would say, I don't even know if I would say they prefer it. I'd say it's just kind of like more normal. It's just what people would normally do. Yeah, so normally you have the smaller number on the left-hand side, but either one of these is perfectly fine. All right, there's no difference really between either one of these. They mean basically the same thing. But since we read from left to right, and our number line as well, right? Smaller numbers are always to the left on our number line, and the bigger numbers are always to the right. Would you agree? Yeah. So that's why we would normally do that. What if they start doing this kind of stuff? What's that? It's not greater. We read left to right, so we would say less than or equal to. Okay, less than or equal to. And of course, one more. That would be what? Greater than or equal to. Yeah. So if I said that A is greater than B, and I did a number line. Okay, here's a number line right there. And if I put an A and a B, so I put a point right here and I put a point right here. Which one of these, A or B, is going to be on the left-hand side, this left point, Ty? B is? That's correct. I got confused myself. So if A is greater than B, right, then the greater number always has to be where on the number line? So the right-hand side. So if A is greater, if it's bigger than B, A has got to be here, and what? B has got to be there. Does that make sense? Yep. Yes. How's that? Is that better? Okay. Let's see. All right, let's just do this. It's kind of the same thing. Let's do another number line. We'll put 3 different letters in here. So it's a line, so I'll put arrows. And let's say I'll put this. I'll put a 0 right there. We have a word for that. Probably learned that in Algebra 1, didn't you? What the word for the 0 is? It starts with an O.
Origin.
Origin, very good. So this would be the origin. So 0 is always considered the origin. It's where you begin, all right? Now, you do have numbers to the left, and you're like, well, yeah, but you don't really begin at 0. But that's kind of why they call it the origin. Because you could start from here. You could go to the left. You could start here, and you could go to the right. So any numbers to the left would be what kind of numbers? Negative numbers, all right? Again, this is real basic stuff. Almost embarrassed to teach it, but but don't worry, we'll be getting into harder stuff later. So so basically, any number to the right is bigger. So if they put a number between 2 and they put a thing right there, a dot right there. That's C. They put a dot right there. It's not exactly what they do, but it's close enough. And then this is actually, we'll do it like this. I don't care. All right. So what if you did this? So which one is bigger? Even if you didn't have the numbers there, you should be able to tell which one's bigger. Which one's bigger?
C.
The C. All right. Which one's the smallest number out of the 3, A, B, and C? The A, and of course the one that's somewhere in between is the B. Yeah. All right. Let's get over that. That's just too easy. All right. Let's talk more about graphing. All right. So this little section we're going to graph real numbers. Did we ever have a definition for real numbers? I don't know if
I think so.
I don't know if we did we? Yeah, we did natural numbers, whole numbers, but real numbers are basically any number that you can think of. Any number on the number line is a real number. Is a real number. Okay, any number on the number line is a real number. So that could be whole numbers, it could be natural numbers, it could be integers, it could be negative. You could have fractions, you could have decimals, anything, even irrational numbers. Numbers that don't repeat a pattern are still considered to be on the number line. Okay, even though they keep on going and it never stops, it's still considered to be on the number line. All right, so every number that you really could think of is a real number. It's pretty easy, right? Just all the numbers are real numbers, basically. All right, so what we're going to do is we're going to graph all the real numbers. And we're going to take portions. I'm going to write that word down. I was going to write the whole definition thing for this one. I'm not going to. We're going to take portions of a number line. Portions of a number line. And we're going to call it something. Oops. Number line. Okay. And what we do, we call the portion of a number line or a part of the number line, we call it an interval. Yes, Ty.
For the real numbers, from 0 to
Yes. Yep. Anything that's on the number line. 0 is on the number line. So we just call it the origin. It just has like a specific name, but it's still a real number and it's still on the number line. Yep. So it's just kind of special, so we just give it its own name. We'll do more. You do x and y axis, y equals mx plus b. Remember that from Algebra 1, Algebra 2? Yes. You remember where the two x and y axes intersect each other? We always call that the origin. Why? Because that's 0, 0. Remember that? Yeah. That's stuff that you've probably done before. Has everybody done that stuff before? I hope so. Okay, good. All right. Alex, question? Yeah, you're getting too deep, so we're not going to get into that right now. So a portion of a number line. So for instance, if you had a number line and you wanted, I'll tell you what, I'm going to do this in a different color. What if you wanted to just figure out from here, I thought I was doing a different color. Let's try this again. I think I was already selected on something. Let's go red. It should work now. Okay. So what if, I'm going to make this a little bit bigger. What if I just wanted to talk about the section, like from here to here? So I'm not just talking about one number, I'm talking about a portion of the number line. You know what I mean by portion? A part of. So what if I want to just talk about that little section of the number line right there? Okay, we call that section, that red thing right there, we call that an interval. All right. So what we need to do is we need a way to write an interval, and so we use this thing called interval notation. I'll just, since I got that word interval right there, I'll just put notation next to it. Now this may be something that you did, maybe you didn't do in Algebra 2. I'm not really sure. Maybe even in Algebra 1, you might have done this interval notation thing. So, for instance, what if I said to graph, I'm sure this is going to look very familiar to you. What if I said graph x is greater, I tell you what, I'm going to start off, even easier. I'm going to say just graph x equals 5. Couldn't get a whole lot easier than this kind of graph. All right? So let's put 6. Let's put 4, 5, 6, 7, 8. Every time you do a number line, you don't have to always have a 0 in there. A lot of people think you always have to have a 0. But what if you wanted to graph the point 1,257? You wouldn't want to put a 0 there and 1,257 marks after it, would you? That'd be ridiculous. So same thing with 5. I don't even need to put the 0 in there, but I do put some numbers in here. So what if I wanted to graph that? How do I graph that on a straight number line like that? What do I do to it? It's not hard. It's real easy. What do you do? Just put a dot on it. That's all you do, okay? Put a dot on it, all right? Right there. There you go. There's your first graph. That's how you graph x equals 5. Well, we're going to go a little bit more. We're going to do a portion of the graph this time. We're not going to do the whole graph. We're not going to do just one point. We are going to do a portion of the graph. So let's do that. Let's do this. Put the arrows here. And let's do this. We'll put the same numbers, 4, 5, 6, 7, 8. But this time what I'm going to do is I'm going to graph x is greater than 5. Okay, so what do you think?
Isn't it open circle to y?
Yep. Now back in the day, in Algebra 1, maybe even in Algebra 2, that's what we did. We used open circles, and then we used what when it was greater than or equal to? A closed circle. We used a closed circle. Remember, everybody remember that? Raise your hand. You remember open circle, closed circle? Yeah, sure. But now we're doing something a little bit different. We're making it a little bit fancier. All right? We're going to use this thing called interval notation. And this is what interval notation does. Instead of an open circle, we use a parentheses. Instead of a closed circle, we use a bracket. Okay? That's really the only difference. All right? But when you get into upper math, they stop using the open circle, closed circles. They use that when you're a little kid. But then when you get older and you start doing some heavier math, then they go to this interval notation thing. All right? So the open, I'll just put open, is a parentheses. The closed is a bracket. All right? Everybody with me on that? Let's do one more thing before we graph this thing. What about infinity? If I went to infinity, if I kept on going, would that be an open bracket or would it be a closed bracket? Or I'm sorry, open parentheses or a closed bracket? What do you think? Infinity. Why open? Because it goes forever. You never get there, right? Closed means it stops right there. Is there any place on infinity where it stops? No, so we're not going to use a closed bracket. We're going to use the open parentheses. Make sense? So every time you see parentheses or every time it keeps on going, this keeps on going, doesn't it? X is greater than 5 because it keeps on going forever and ever to the right. So what we're going to do when we do our interval notation, we're going to use a bracket after infinity. Okay? So let's graph this thing. Let's do it in a different color. Use that red again. So x is greater than 5. So this is open, isn't it? So what kind of symbol are we going to put at the 5? Just say it. The parentheses, right. Now, it's going to go to the right, so we're going to put a left parentheses. I thought I made that a different color. Keep doing that. Let's try this again. Let's go yellow. Okay, so we actually put a parentheses there, okay? And then it keeps on going to the right. How do we indicate when on our graph that it keeps on going to the right? Yeah, or you, not just an arrow, but you shade it in. Right, you shade it in a little bit, all right? So I'm just going to use a thicker marker. I'm going to shade it in. And now what do you do after you shade it in to indicate that it's going to the right? Now you can put an arrow there, all right? Everybody with me on that? So that's how you would graph it right there. So that's the graph. That's not really interval notation, but that's the graph. Interval notation is basically all the stuff that's in yellow, but we're just going to write it out. So what I'm going to do, I'm going to say, I'm going to start off with the parentheses. Now, what's the very first number that it hits? It's 5. Actually, it doesn't hit 5. It's open, but it's just past the 5, okay? As close as you could possibly get past the 5. And then it goes to, so we put a comma there. All right, so this is a little different probably than you've seen before. We put a comma, and now we say where it ends. Where does this thing end?
Infinity.
Infinity, right. So you know the symbol for infinity?
Sideways.
Yeah, it's like a sideways 8, okay? That's the symbol for infinity. Now, we need to close this off. Do we actually put a bracket or do we put a parentheses? Put a parentheses. Why? Because infinity never ends. It keeps on going forever. Exactly. So this right here is our if I could say it, interval notation. Right? This right here is interval notation. It's basically the same thing that you've done in the past, but the symbols are just a little bit different. Okay?
It's
not too hard, is it?
Shane Caleb, Xavier Moore, Sam Clausen, Carter Treka. Thank you.
If they have you move stuff, I'm going to be ticked off. They did that. My geometry teacher when I was in high school, people would call a student out of the office and she says, can so-and-so come to the office? And she'd say, nope, they're in my class. They're not leaving until class is over. I was always so impressed by that. She was this little old lady and, sweetest lady in the world, but she would not let kids out of the class no matter what. I was like, man, so I should be like that. But I'm a pushover. But I did tell them not to go when the kids came to get them. But anyway, is there a question? Was there a hand? No? Okay. So that's interval notation. So let's do this. Let's do one more thing. Forget what we called it. Somebody look in their notes. Remember I said I'd never had a name for that before where we did that such that. Remember we did the braces, X, all the real numbers X, such that. What is it called? Set builder notation? Okay. So here's the set builder notation of this, right? It's kind of weird. It seems like it's a waste of time, but you're going to see it, all right? So that's all I can say about it. I don't know who came up with this, but you put a brace. What I'm going to write means the same exact thing as that graph. It means the same thing as the interval notation, but I'm going to put it in this set builder notation format, all right? So here's what we do. We say X or all the, what did I say? It said all the numbers X or all the set of all X. Is that what I said?
Yeah,
the set of all X such that, right, that little bar right there means such that X is greater than 5. All right, so that's the set builder notation, that's the interval notation, and that's the graph. All three of those mean the same thing as that. All right, so there's 4 different ways to write X is greater than 5. You could just say X is greater than 5. You could graph it. You could put it in this notation, or you could put it in this notation. Yeah, let's do one with a closed bracket, okay? And I'll show you. It's a good question. So let's go back to the white. Let's make a graph again. And then I'll tell you what we're going to graph here in a second. So let's do this. Actually, they're going to give it to you in interval notation, and then what we're going to graph it, then we'll put it in that set builder. I tell you what, let's put in that set builder notation first, and then we'll put it in interval, and then we'll graph it. Or vice versa. It doesn't matter which one we do. So here's what they could do. They could give you something that looks like this. Okay? So x such that x is less, or all this, always free. I usually just say x such that. So all this set of numbers of x, or whatever I said they say, x such that x is less than or equal to 7. So there's your or equal. So that means we're going to have a bracket in there, correct? So let's see what we're going to do. So it's going to be less than 7, right? Less than or equal to 7. So I'll put the 7 up here, and then I'll just put a few numbers on here. I don't have to like put a whole bunch of them. I'll just put a few of them in there like that, okay? I know I'm going less than, so I put the 7 to the right. Now, if normally back in the day in Algebra 1 and Algebra 2, we probably would have put a closed circle at 7, wouldn't we? But what are we going to do now that we've graduated to college algebra? Put a bracket. And it is going to the left, so I'm going to put my bracket to the left. It's the same thing as a closed circle. Johnson, you getting all this? Somebody tap him. Help him out a little bit. I know, it's almost lunch. It's dark in here. It was pretty warm, but there we go. So, less than or equal. Are you taking any notes on this? You got it all up in your head? Is that what it is? Yeah. It'd be good to take notes. Everybody should be taking notes. So this is less than or equal, but we got to do what to it, though? If I was to graph this thing, yeah, shade it in which direction? To the left. And we don't have to go all the way down. We'll just do it anyway. And then, boom, put an arrow right there, and there you go. There's your graph. So they're going to ask you to do two things. They're going to say graph it, and then they want you to put it into that interval notation form. Once you've graphed it, it's actually pretty easy because the interval notation kind of mirrors what the graph looks like. And so that's what we're going to do. So what do we do with the arrow? What do we put in interval notation? Just tell me. Good time. Yeah, see this arrow right there? What does that indicate? Infinite, right? But it's going to the left. Now, here's something that's a little different. It's going to be negative infinity, all right, because it's going to the left. So you still have infinity down there, but it's in the negative direction. So this way would be positive infinity to the right, and that way to the left would be negative infinity. Make sense? So in our interval notation, we're going to put negative infinity, and then a comma, and then we're going to put what? A 7. Now we got to decide, are we going to use parentheses or brackets? What do we always use with infinity? A parentheses. All right, so we'll close it like this. And this bracket's going to the left, so we put a bracket right there. So these two things really mean the same exact thing. All three of these things mean the same thing. It means all the numbers that are less than or equal to 7. Somebody give me, real quick, a number that is actually less than or equal to 7. Just tell me. 4 is. Give me another one. 2, 6. Less than or equal to 7. 7, right. That's a good one. 7 is less than or equal to 7, right? 6.9. 6.99999999999. I can keep going. That's all less than 7, isn't it? Okay, enough of that. Let's continue. I'm going to give you a couple to try yourself. Put it in your notes. Okay, this is an actual example from the book. Let's put this in white. So this is example 3 in the book. If you look at the book or you look on your PDF where the book is, it's example 3. And they give you 2 examples. And I'm not going to write down what they ask you, but they ask you to graph and to write it in interval notation. Megan, you getting all this? You're writing all this down. It's kind of hard with your hands full of her hair in your hands. So here's the question. They put it in this set builder notation thing. All the numbers x such that x is less than 9. All right, so they ask you to do 2 things. I didn't write it down. I'm just verbally telling you. Graph it and put it in interval notation. Go ahead and do that. And then you're going to do that for this one. Do the same exact thing for this one. X such that x is greater than or equal to 6. All right, so you're doing two things. You're graphing it. Megan, let's go. Come on. Okay. You didn't do these two. All right, so write it down. I want you to do two things. You need to graph it, and you need to put it into interval notation.
That is 6.
Yeah, 6, 7, 8, 9. This right here, that's a 9. Sorry. This is a 9, this is a 6. Okay, so this is x is less than 9. So when we graph it, what kind of symbol do we put at the 9? Parentheses, and it should be kind of facing to the what? Left, correct? Because it says less than, so we're going to go to the left. And now we shade in. Right there. And now put an arrow. There's our graph. Pretty easy, right? It's kind of sloppy looking, but you get the idea. Right? And so now the interval notation. So we got parentheses on both of them, right? Because this is infinity, and that's a parenthesis. So we got parentheses on both of them. And then to the left is going to be what? Negative infinity. And then to the right is going to be 9. Now remember I asked you to yell out those numbers with the 7, you know, the stuff that's less than or equal to 7. But this is not less than or equal to now, is it? It's just less than 9. So could I yell out 9 and that fit this? No, 9 is not included in here. Remember, because it's open. Right, it comes really close to 9. It's like 8.9999999, but it doesn't actually hit 9. Okay. What about this one? X is greater than or equal to 6. So greater than or equal to. That's the key here. Or equal to. What am I going to put at the 6? A bracket, and it goes to the right. Okay, so I'm going to make my bracket go to the right. Yep, I'm going to shade this thing. And then I'm going to put an arrow there, and there's my graph. Simple graph. And now we put the interval notation. So basically, we just look at the graph, and that way we can figure out what brackets and parentheses. So I put a bracket, put a 6, comma, and then where's this go? Do I put a 9 here? Does it stop at 9? It keeps on going because that arrow, it's infinity, and it's positive infinity. Infinity is always a parentheses because it never hits it. And then there we go. So there you go. It's pretty simple. Do you agree? Would you like to see these on a quiz or a test? Yeah, of course you would. Yeah, pretty easy. All right, let's do one. Now this is only going in one direction, right? Let's do a thing called a compound inequality. All right. You remember in English class, didn't you do like compound sentences and stuff like that? You ever remember that? Simple sentences, compound, complex. What? You never did those things? I remember that from, how old am I, 40? So it's over 40 years ago. And I remember it. Compound sentences? You never did that in English class? This is called compound inequalities. Yeah, it's probably one of the other. All right, so let me do one. I'll just show you one right here. That's supposed to be less than x, which is less than. Remember we did the thing backwards? This is where that comes into play. That's why we talked about this earlier. All right? With this right here? So let's write this. We can write this like two different ways. Well, hopefully we'll get it now. So watch. I could write this two different ways. Let's take this just right here. Okay? So what does that mean? It just means what? X is less than 8. So I could say x is less than 8. Okay? I'm going to put an and in here. That's the compound because there's two different things here. There's this one right there, okay? And then there's also this one right here. But remember we talked about reading it backwards or from right to left? So let's actually write it so that I read it from left to right. So this is really x is what? Greater than negative 2, right? So that's what I'm going to do right here. X is greater than negative 2. Doesn't this and this mean the same thing? It's just a little bit easier to read it like that when x is on the left. You with me on that? So what I want to do now is I want to graph this thing. So this graph's going to be a little bit different. Just to make it a little easier, so x is on the left. Because remember, I'm reading this from right to left. If I read it from right to left, it's x is greater than negative 2. So when I say x is greater than negative 2, I'm going to write x first, then my greater sign, and then my negative 2. Yeah, but saying negative 2 is less than x sounds, I don't know, it's just more complicated for me. I like the x on the left-hand side and then the number on the right. Let's just finish this up real quick and then we can think about it later. So this is saying both things. X is greater than negative 2, so let's put a negative 2 right there. That's my smallest number, right, between the two? And then x is, and then let's put an 8 right there. Okay. Exactly right. So what this means, what this thing means right here, let's change color and I'll shade it in. Now, it doesn't say or equal to, does it? So what kind of a thing are we going to have? Have parentheses, right, here and here. So this means this. Basically, it means that x is between negative 2 and 8. So pick a number between negative 2 and 8. Somebody give me one. 3, 4, 6, 1. Okay, what about negative 3? No, it's not between, is it? What about 9? No. Okay, what about 2/3? Yes, it's between negative 2 and 8. Yep, it fits in here somewhere, doesn't it? Right? Any number between negative 2 and 8 works for this thing right here. That's what the graph is showing. Okay? Do you see why we wrote it x is greater than negative 2? It's just a little bit easier because there's the x. See, this would keep on going, but since I have the and, right, that means it has to satisfy both of those things. It has to be bigger than negative 2, and it also has to be what? Less than 8. So those are your numbers in between.
How would we write that?
Well, that would be the graph of it. Okay, what if we did interval notation? Actually, yeah, let's do interval notation. So what would interval notation look like here? Well, we got a parentheses, we got a negative 2, and then what do we put in between? A comma. Now, where does it go? Does it keep on going? We're not done yet. You guys are acting like we're done. We're not. Starts at negative 2, and it keeps on going to where? Infinity? It just goes to 8, right? So we have no infinity on these. But you do put that. Now, it doesn't go all the way to negative 8. It goes just before negative 8. And it goes just after negative 2. Yeah, just positive 8. Yep. Right there. This is positive 8. That's negative 2. So this means the same thing as this graph. It means the same thing as these two things broken up. And it means the same thing as this compound inequality. Okay, so all four of these really represent the same exact thing. It just says, I'm going to pick some numbers between negative 2 and 8. Does that make sense?
Yeah.
Okay. Well, I have more to do, but we don't have enough time. Was it 10 after 8? So we're out of here? So I'll give you some homework on Monday instead of today. So I'll give you the weekend off. Have a seat. No? After class is over. Save my hugs for after class. So, listen. You guys listening?
Yeah.
Let me turn this off.